All right, let's dive in. Today, we're tackling one of the coolest tricks up a mathematician's sleeve, standard form. You might also know it as scientific notation. Basically, it's the secret code for wrangling the universe's most gigantic and unbelievably tiny numbers.
Just look at this thing. That's roughly how many kilometers are between the Earth and the Sun. It's a beast of a number, it's awkward, and let's be honest, you're just begging for a typo. Counting all those zeros, what a pain, right?
Of course there is. You can bet that scientists and mathematicians got tired of all those zeros pretty fast. They needed a smarter, more elegant way to handle these numbers. And that's exactly what standard form is.
You know, this isn't just about saving a little bit of time. If you're working in a field like astronomy or physics, you're dealing with these kinds of numbers all day long. Writing them out the long way isn't just a drag, it's a recipe for disaster. One tiny slip up with a zero and your whole calculation is toast.
And this is where standard form swoops in to save the day. The best way to think of it is as the ultimate mathematical shorthand. It's a universal system that lets us write any number, no matter how ridiculously huge or small, in a way that's clean, simple, and way harder to mess up.
So what does it actually look like? Well, every number in standard form has this basic recipe, some number a times 10 to the power of some other number n. A is our main number, and n is just an integer. It can be positive, negative, whatever. But, and this is a big but, there's one rule to rule them all. Okay, listen up, because this is it. This is the single most important part of the whole thing. Burn this into your brain. The number a absolutely must be 1 or greater, but it has to be less than 10. It can't be 10. It's not a suggestion, it's the law of standard form. Get this, and you've got the core idea down.
So, something like this, 4.5 times 10 to the fifth, perfect? Absolutely perfect. Why? Because 4.5 is right in that sweet spot between 1 and 10. Check, that's correct.
But what about this one? 12 times 10 to the 5. No way. That is not correct, because 12 is bigger than 10. It breaks our golden rule, so that's a big X.
And on the flip side, 0.5 times 10 to the 5? Also a fail. It's too small, it's less than 1. You've got to be in that Goldilocks zone. Not too big, not too small.
All right, so we know the rule. Now for the fun part. How do we actually convert regular numbers into this awesome format? Let's get into the mechanics.
You know, the secret sauce is all about moving that little decimal point. And which way you slide it tells you everything you need to know about the power of 10, whether that n is going to be positive or negative. Let's break it down.
Okay, let's take a big number, say 45,000. Where's the decimal? It's kind of hiding at the end, right? To get our a into that sweet spot, we have to hop that decimal 4 places to the left. And because we went left, our power is a big, happy, positive 4. Boom. 4.5 times 10 to the power of 4.
Now let's try a tiny one, 0.00072. This time, to get our a to be 7.2, we're hopping that decimal 4 places to the right. And a move to the right, that means our power gets a negative sign. So we're talking 7.2 times 10 to the power of negative 4. See the pattern? Left is positive, right is negative. Simple as that. Okay, so writing the numbers is one thing, but the real game, especially when you're staring down an exam paper, is calculating with them. This is where you really prove you know your stuff.
And listen, this is super important. You have to use 2 totally different playbooks here. For multiplying and dividing, it's all about your index laws. But for adding and subtracting, whole new ballgame. You got to make those powers of 10 match first.
Let's walk through a multiplication. We've got 4 times 10 to the fifth times 6 times 10 to the fourth. The trick is to just regroup them. Put the regular numbers together, the 4 and the 6, and put the powers of 10 together. We know from our index laws that when you multiply powers, you just add the little numbers up top. So 4 times 6, that's 24. Easy. And 10 to the 5 times 10 to the 4 gives us 10 to the power of 9, so we get 24 times 10 to the 9. And right here, this is the trap. This is where so many people would just stop and move on.
But wait a second. Is it right? Let's go back to our golden rule. Is 24 between 1 and 10? Not even close. It's way too big. So our job isn't done yet. We have one more really important step.
Here's the fix. You take that 24 and you put it into standard form. That's just 2.4 times 10 to the power of 1, right?
Now, just slot that back into our equation. So we have 2.4 times 10 to the 1 times the 10 to the 9 we already had. Combine those powers, and you get your final, perfectly correct answer, 2.4 times 10 to the power of 10.
So who cares, right? Why does this even matter? Well, let's do something cool with it. Think about the closest star to us, Proxima Centauri. It's a ridiculously long way away, about 4 times 10 to the 16 meters. We know light travels super fast, 3 times 10 to the 8 meters every second. To find out how long its light takes to get to us, we just divide the distance by the speed. And with standard form, what would be a nightmarish calculation is actually pretty simple. Turns out it's about 1.33 times 10 to the 8 seconds. That's amazing.
Okay, let's wrap this up with some pro tips. If you want to absolutely crush these questions on an exam, it's not just about knowing how to do it. It's about knowing how not to mess it up.
Here are the biggest mistakes people make. Number 1, forgetting that final adjustment. Always check your A. Number 2, your calculator might spit out something with a big E in it, like 3.4E5. That E just means times 10 to the power of. Don't forget to write it out properly. And finally, be so careful with negative powers, especially when adjusting. Decreasing -3 gives you -4, not -2. It's easy to get twisted, so watch out.
To make sure you never get caught, I want you to use this little 3-step check every single time. First, the A check. Is A in the zone between 1 and 10? Good. Next, the N check. Is your power N an integer? Does the sign make sense for the number? Great. And finally, the SF check. Did the question ask for a specific number of significant figures? Double check you've rounded correctly. A, N, SF. Simple.
So there you have it. You're now equipped to handle the biggest and smallest numbers the universe can throw at you. Standard form isn't just some boring math topic, it's a real tool for figuring out the world. So the only question left is, now that you have this power, what problem are you going to solve first?
Thank you so much for watching! And for more helpful videos, math and science videos, don't forget to like this video and subscribe to our channel. See you soon!